Hello dear students, my name is Ajit Singh Rawat and I am a mathematics teacher, and today I will be taking up the topic continuity of class 12th. The learning outcomes of this lesson are to understand the concept of continuity of a function at a point. The concept of continuity of a function at a point graphically, and in the later part of the class you will be able to check the continuity of a function at a point using a mathematical definition. So let us start. This topic is continuity of a function at a point. Continuity of a function at a point. To discuss this topic, let me start with two informal examples. Say, consider a function fx which is 1 for value of x less than equal to 0 and 2 if x is greater than 0. Consider this function, right? So, the graph of this function will be like this. This is a piecewise function, and the output will depend on the input x. Accordingly we will have the output. So for the values of x which are 0 or less than 0, the output is 1. So for the values of x, here x is negative and on this side x is positive. Along this axis we have the input x, and along y-axis we have the output, that is f of x. So for negative real numbers and 0, the output is 1, and it is clear from the definition of this function that for the values of x greater than 0, the output is 2. So the graph will be like this, and I have to exclude this point and I have to include this point, because at x equal to 0, here it is 0, because at x equal to 0 the value of the output is 1, right? So this is the graph of this function. Okay, let me take one more example. Try to draw the graph of this function fx equal 1 for x not equal to 0, otherwise it is 2. So the graph of this function is again very simple. For if x is equal to 0, if the input is 0, the output is 2, and for the values of x which are not equal to 0, means for all other values the value of the function is 1. And I have to exclude this point, because at x equal to 0 the value of the function is 2. So here are some piecewise functions and their graphs. So you can see the break. When I try to draw the graph of these two functions, suppose I try to draw the graph of this function in one stroke. In one stroke I mean without lifting my pen. So let's see if I can do that. So for drawing the graph of this function, I have to draw it like this. Then at this point, at x equal to 0, I have to lift my pen, and then I have to start from here. So I am unable to draw the graph of this function without lifting my pen. So there is a break at what value of x? At x equal to 0. And again, if I try to draw the graph of this function, it will be like this. Then I have to lift my pen to plot this value. Then again I have to start from here. It means I have to lift my pen. In both the cases I have a break at x equal to 0. So by these two examples I can say the function fx is not continuous at x equal to 0. I can say the function is not continuous at this point x equal to 0. This function as well as this function. Okay, I have drawn the graphs of the two functions again so that I can explain what is happening over here. For this function, what will be the left hand limit at x equal to 0? What will be the left hand limit at x equal to 0? For this, see, left hand limit at x equal to 0 means the value to which the function is approaching when x is approaching 0 from the negative side. Here is the number 0, and if we approach this number from this side, that is from the left hand side, we approach this number, the value to which the function is approaching is 1. So the left hand limit of this function is 1. And if we see what is the right hand limit at x equal to 0, so it will be limit x approaches to 0 from the positive side of fx, means the value of fx when we approach x from the right hand side, from the positive side of x. It means from here we are approaching x equal to 0. So you can see the value is approaching to number 2. As we are approaching towards 0, the x is not equal to 0, so it will not be 1, it will be 2. However close we may get from the positive side towards 0, the value will always be 2. So in this example we have seen that LHL is not equal to RHL, so limit of the function at 0 does not exist. This is happening because the left hand limit and the right hand limit at x equal to 0, they are not same. So if the left hand limit and right hand limit are not the same, the limit does not exist. So at that point we have a discontinuity. The point where the function is not continuous, we call it a point of discontinuity. So in this function we have the discontinuity at x equal to 0, and you can see now mathematically why this is happening. This is because at 0 the left hand limit of the function and the right hand limit of the function is not same. Okay. Now let us discuss this example. In this example, the left hand limit at x equal to 0, that is if we approach 0 from left side, the value to which the function is approaching is 1. And the right hand limit at x equal to 0, it means the value of the function when we approaches x from the positive side is again 1. Here we have the limit of this function when x approaches to 0 from either side, same, and we say the limit exists. This limit exists, it is 1, but still the function is not continuous at x equal to 0 because the value of the function at 0 is not equal to 1. So from these two examples we can conclude that for a continuity of a function at a point, for a function f is continuous at x equal to any point, say a, if and only if limit of x approaches to a of the function, it exists and should also be equal to f of a. So, and this limit will exist definitely when LHL at x equal to a is equal to RHL at x equal to a, and the value of the function of at x equal to a. These three things have to be equal for the function to be continuous at the point x equal to a. So this is the mathematical definition of continuity at a point. Students, let us recapitulate what we have done till now through these three figures. In this figure, you can see the graph of this function. It is at x equal to a, there is a break, and x equal to a will be the point of discontinuity. And what mathematically will happen here, if you find the left hand limit and the right hand limit, the two limits, they will not be equal, and the limit at x equal to a of the function does not exist. In that case, we have point of discontinuity. And in this case, even though LHL is equal to the RHL, LHL and RHL both are same, but the value of the function at a, it is not same to LHL and RHL. Means the limit of the function fx at a, it exists, but the problem is it is not equal to the value of the function at that point. So again we have a point of discontinuity. And in this last figure, as you can see, at x equal to a, the LHL and the RHL and the value of the function at a, all three things are equal. So we say a is not a point of discontinuity, and you can see from the graph, I can draw the graph in a single stroke. There is no point of discontinuity for this function. Here x equal to a, there is a point of discontinuity. Here at x equal to a, there is a point of discontinuity, but in this case we have a continuity at point A. Thank you.